let's talk about indices in this video. So we're going to talk about everything about indices. Okay, how to simplify indices. First, we're going to start about the basics that you're supposed to know about indices. Then we're going to talk about the laws of indices. There are some rules that you're supposed to follow every time you're solving a question relating to indices. Then we're also going to solve some simplifying problems, how you solve indices. Okay, then afterward we're going to talk about fractional indices. Then we're going to solve some equations. Then this topic is done. Okay, so what are the basics? What are we supposed to know? So when we talk about an index or an indice, these are also called exponents, okay, or exponentials. So if I've got a to the power 5, what a to the power 5 means, it means you're multiplying a by itself 5 times. So it means a multiplied by a multiplied by a multiplied by a multiplied by a. Okay, that's what it means. Now the a in this case is the base. Then the 5 in this case is the exponent. The exponent is also called the power. It is also called the index. So basically these are just the basics about indices. So if I write 5 to the power, let's say 4, what 5 to the power 4 means, you're multiplying 5 by itself 4 times. So it is 5 multiplied by 5 multiplied by 5 multiplied by 5. That's what it means. If I've got, let me say, 3 to the power 6, what this means, I'm just multiplying 3 by itself 6 times. 3 multiplied by 3 multiplied by 3 multiplied by 3, 3, 3 and 3. Okay, they're supposed to be 6 like that. However, you can also move in the opposite direction. Let's say they've given you to solve 3 multiplied by 3 multiplied by 3. What is the answer? So if you want, you might solve it just the way it is, but if they want you to express it as an index or as an indice or as an exponent, those are just the same names. It is just the same as 3 to the power, how many 3's? 1, 2, 3. There are 3. So it means it will be 3 to the power 3. Okay. Another example that I can give, if let's say I've got x multiplied by x multiplied by x multiplied by x is equals to what? So if they tell you to express it in terms of indexes, you're just going to count how many x do we have. So we're going to have x to the power, how many x's do we have? We've got 1, 2, 3, 4. So we've got 4 x's, so it will be x to the power 4. So basically these are the simple rules about indexes or indices. So basically that. Now what are some of the rules before we start solving some questions? So rule number one is that any number to the power 0 is 1. Okay, any number to the power 0 is 1. So if I've got a number, let's say 2 to the power 0, that will give me a 1. Okay, if I got, let me say, 100 and the power is 0, the answer will be a 1 still. However big the number is, however small the number is, the answer will still be a 1. So that is important. So let me just write that. Any number, when I say NO, that just means the number, any number to the power 0. To power 0 is equals to a 1. Okay, an example that you can give, 3 to the power 0, that will be equals to a 1. Rule number 2 is that any number to the power 1 is the number itself. Okay, so any number to the power 1, any number to power 1, okay, to power 1 is itself. So what we mean is, if I've got 3 to the power 1, the answer will still be 3. Likewise, if I have, let's say, 10 to the power 1, the answer will be 10. So any number, as long as it has a power of 1, is itself. Then rule number 3 that we need to also consider is that when you multiply the powers with the same base, you have to add the exponents. So let's say when you're multiplying, so every time you're multiplying, then those numbers have the same base. If they have the same base, you add the powers. Okay, add powers. This is rule number 3. So for example, if I've got, let's say, 2 times 2, if let's say the first 2 is to the power 3, the other one is to the power 2, because the base is the same, the base is this 2, then the powers, it is the 3 and the 2. So basically, if the base is the same, you're just going to add the powers. So if I'm going to do that, what am I going to have? I'm just going to get first 2 as a base because it's common. Then I'm going to now add the powers, this one and this one. Now if I add them, what am I going to have? I'm going to have 3 plus 2. Therefore, if I now continue, I'm going to have 2. Then I'm going to add the powers. 3 plus 2, that is a 5. So basically, that would be our answer if they tell us to express it in index form. In index form, you always have the base and the power. However, if they want us to solve it, we are going to multiply. What does 2 to the power 5 mean? 2 to the power 5, we said, means 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. You are multiplying 2 by itself 5 times. So that's what it means. So basically that. If they tell you to simplify completely, it means you have to find the answer. 2 to the power 5, you know that it's just going to give you 32. Okay? Yeah, like that. So basically this. So that is rule number 3. The last important rule that you should understand here is, let's say, rule number 4. Now when you divide the powers with the same base, what are you supposed to do? So if now you are now dividing, what is going to happen? So every time you are dividing, allow me to rub this side. So every time you are dividing, when you divide the powers with the same base, so the base should always be the same. So these numbers have the same base. You are subtracting the powers. So we're going to say subtract powers. Okay, so here, if I'm saying, let's say 2 to the power 2 divided by, since we're saying we're dividing, divided by, let's say 2 to the power 1. So what this means, because we are dividing and the bases are the same, we're just going to subtract the powers. So this will be equals to, I'm going to have 2, since the first power is 2, so I'm going to say 2 minus 1. 2 minus 1. Therefore, I'm going to have 2 to the power, 2 minus 1, it is just a 1, okay? So I have 2 to the power 1. Then what did you say any number to the power 1 is? any number to the power 1, we've said it is itself. Okay, so basically these are the rules on indices. Very important. So before we start even solving questions, let's maybe just review. Let's say this is a review of the rules that we're just from talking about, so that they cement. Then as we are starting to solve questions, we'll be just now applying. So any number to the power 0 is 1. So if I've got 1 to the power 0, it will still be 1. If I've got 2 to the power 0, it will still be 1. If I've got 1,000 to the power 0, it will still be a 1. Good. Any number to the power 1 is itself. 2 to the power 1 is equals to 2. 100 to the power 1 will be equals to 100. Okay. 6 to the power 1 will be equals to 6. So that's what we're talking about. But what if you're multiplying numbers with the same base? Let's say 2 to the power 2 multiplied by 2. Then let's say because they're multiplying, then we put powers like let's say 4 and 6. So what this one is going to equate to, because the base is the same and we are multiplying, so I'm going to say 2. What am I going to do to the powers? So you can be pausing the video to just try out. So you're going to have 4 plus 6, right? You're adding the powers. Now if I add 4 plus 6, I'm going to have 2 to the power 4 plus 6, that gives me what? 10. And what is 2 to the power 10? It means you're multiplying 2 by itself 10 times. You're going to be multiplying 2 by itself 10 times. So that is like a very big number. But mostly if they've just told you to end as an index, you're just going to leave it there. Let's solve another one. Let's say I've got 4 to the power 1 multiplied by 4 to the power 2. So what is this one going to equate to? I'm going to have 4 to the power. What am I going to do to the powers? I'm going to add them. I'm going to have 1 plus 2. So I'm going to therefore go for 1 plus 2, that gives me a 3. Okay, then what this means is 4 times 4 times 4. Then you can find what this is. Okay, you start multiplying. What is 4 times 4? It gives you like 16. 16 times 4. You find again. Again, 4 multiplied by 6, that is like 24. 4 multiplied by 1, that is a 4. Plus this 2, that is a 6. Okay, you're going to have 64 like that if they tell you to find the actual answer. So basically, let's solve the last question here. If I've got, let me say, 3 to the power 1 multiplied by 3 to the power, let's say 3. So what I'm going to have, because the base is the same, I'm going to get it just 3. Then the powers, because we're multiplying, I'm going to add them. So I'm going to have 1 plus 3. 1 plus 3. So the base is still the same. I'm going to maintain a 3. But the power, when I add 1 plus, what is 1 plus 3? It is a 4. Okay, now if I continue, if I now simplify further, what am I going to have? 3 to the power 4, that just means you're multiplying 3 by itself 3 times. 3 times 3 times 3 times 3. Okay, now if we simplify it further, what are we now going to have? 3 multiplied by 3, that is a 9. 3 multiplied by 3, that is another 9. Okay, so times 9. So this is 9 times 9. What is 9 times 9? 9 times 9 gives us 81. Okay, basically that. Then what if now you are dividing? Let's say 3 divided by 3. Let's say this is to the power 1, this is to the power 4. Okay, not let me just put, let's say 4 this side and 1 this side. What this is going to equate to, you get the base, because the base is the same, so you're going to add the powers. The powers in this case, we've got 4. You're going to subtract the powers. So it will be 4 minus 1. And when you subtract the powers, what do you have? I'm going to have 3. 4 minus 1, that is a 3. Okay, therefore this is what you're supposed to now solve. 3 to the power 3, 3 to the power 3 just means you're multiplying 3 by itself 3 times, so that is 3 times 3 times 3. Okay, 3 times 3, that is a 9. A 9 multiplied by another 3, that gives us what is it, 27? Yes, like that. So that's how you're going to solve. So on this one, let's solve another question. Let's say you have 6 to the, let's say 6 divided by 6. Then let's say the power is let's say the power here is 2, the power there is, they haven't put anything. If they haven't put anything here, always assume it as a power of 1, because any number to the power 1 is itself, right? So always assume that the power is 1. So what are you going to do? You're going to say 6, then you're going to add the powers. What are the powers? What powers do we have? Here we have a power of 2. What about here? What power are you going to have? Because there's nothing except it has a power of 1, right? So you're going to say the powers are 2 plus 1. Okay, then 2 minus 1 actually, because we are dividing 2 minus 1. Therefore, now what are we going to have? We're going to have our 6. Then what are we going to do to the powers? We're subtracting 2 minus 1, that is a 1. Then any number to the power 1 is itself. So our answer here is just a 6. Okay, let's solve the last one. Let's say you have let's say 2 to the power 6 divided by 2 to the power 3. So what are you going to have? Our answer is going to be 2. Then to the powers, what are you going to do? We are subtracting them because you are dividing. So we're going to say 6 minus 3. Then what are we now going to have? We're going to have 2. 6 minus 3, it is just a 3. Then 2 to the power 3, what does it mean? You're multiplying 2 by itself 3 times. So this is 2 multiplied by 2 multiplied by 2. Then what is 2 multiplied by 2? That gives us a 4. Then there's a times 2 again. 4 multiplied by 2, that is an 8. So basically that would be our final answer. Okay, so basically that is just the introduction about indices. And now, how do we simplify indices? Okay, so you can be trying these questions as I'm writing them down. Okay, so simplifying the following as powers. So number 1, let's say you're simplifying as powers. Okay, so if we're simplifying as powers, let's say the first question is we've been given 2 multiplied by, let's say 2 to the power 2. How can you simplify this one as a power? So when they say simplify as a power, that doesn't mean they want the answer. You just have to have your answer which has a power. Okay, so in this case 2 multiplied by 2, what did we say when you are given when you are multiplying? So every time you're multiplying, you're going to add the powers if the bases are the same. So in this case the bases are the same, so we're going to have 2. This, you haven't given us a power, so it has a power of 1. So in this case you're adding 1 plus 2. We said every time you're multiplying and the bases are the same, you're adding the powers. So we're going to have 2. 1 plus 2, that is a 3. Then 2 to the power 3, that means 2 multiplied by itself 3 times. But we're not finding the final answer. They just want to simplify as a power. So we leave it as a power because it has a power there. So that's how you're going to solve this one. Let's solve another one. Let's say 2, we've been told to find okay, let me just use a different page. We're still simplifying as powers. So if, let's say you are given a to the power, let's say 2 minus x, we are multiplying with a x plus 1. Okay, so because the base is the same, what we're going to do to the powers, are going to still add them. Okay, so in this case I'm going to get a Then to the powers, what am I going to do? Add them. So I've got 2 minus x. I'm adding it to x plus 1. Okay, what am I now going to have? I'm going to have a, then to the powers I'm going to just add. So I've got 2 minus x plus 1. Then what am I now going to have? I'm now going to add the powers. So 2, let's put the like terms together. So this is minus x, this is plus x, and they're adding. So every time you're adding and the symbols are different, you are going to be subtracting. Okay. Excuse for me for that. So I've got minus x and plus x. So what does that give me? It's giving me 0. Okay, so I'm going to have a 2, then I'm going to have a 1 there, plus 1. Okay, so plus 1 like that. So basically I'm just going to have a to the power 3. Okay, so that's what you're going to have. So that is very important for us to understand. Let's solve another one on simplifying as powers. Let's say you are given m to the power 3 divided by m to the power 2. What are you going to do? Because you are dividing, get the base, which is the same m, then to the powers. What do we do to the powers when you are dividing? You are subtracting them, right? So you are going to have 3 minus 2. So now when we simplify this one, I'm going to have m 3 minus 2, that gives me a 1. Okay, any number to the power 1 is what is itself. So you're just going to have m there as our answer. Okay, let's simplify another one. Let's say you are given x, there is y, and you have a power of 3. You are dividing this by x, y. So what are you going to have? So because we are dividing, so what we are now going to do is, let's distribute, let's get, because the powers are the bases are the same, we're just going to get the bases. Okay, then what do we now do? So we are going to have x, y. Here we have 3. Here we haven't been given any power, so the power there is 1. So what do we do to the powers? We subtract them because we are dividing. So we are going to have 3 minus 1 as the power. Then what do we do? xy. Let's solve the powers. 3 minus 2, 3 minus 1, that is a 2. Okay, you can either leave it here or distribute the 2. What this 2 means is that this 2 is multiplying on x, this 2 is also multiplying on y. So therefore your final answer, if you're going to simplify it, you're going to have x to the power 2, y to the power 2. So that will be our answer. Let's solve another one. Let's say I have x to the power 2, y to the power 3. Then I've got 2 outside. So what the 2 does is going to multiply with the one that is on the x. It's also going to multiply with what is on the y. Okay, so let's just do that. So what are we now going to have? We're going to have x, this 2 multiplied by the 2 on the x, we're going to have a 4. Then we come to y. Again, we're going to multiply this 2 with the 3 that is on the y. So when we multiply them, what are we going to have? We're going to have a 6. So basically this will be your final answer. Okay, let's solve another one. Let's say you are given a to the power 3, then there is 4. So what does this mean? What it means, you're multiplying 4 with the power of a, which is 3. So in this case, what would be our answer? I'm going to have a. Now if I multiply 4 multiplied by 3, what do I have? I have a 12. Okay, so basically this will be our final answer. We are just expressing as powers. Okay, so that is what we have. Let's say again we've been taught to simplify c to the power 4 divided by c squared. What are you going to have? So like we've said, you can be pausing the video to try out these questions. So because we are dividing and the bases are the same, what are we going to do to the powers? So we're going to get the base. What are we going to do to this power and that power? We are going to subtract, right? 4 minus 2. So what now do we have? We're going to have c 4 minus 2, that is a 2. So that will be our final answer, c to the power 2. Let's solve another one. Let's say you are given 4 a to the power 3 times 2 a to the power 7. Okay, so this one is a bit different. So first what you are going to do, multiply the numbers. Okay, this and this is not the same number, right? But a and a, they are the same. You can do the indices the way we did it. Okay, so 4 multiplied by 2, that will give us an 8. Then we're also going to multiply the letters on them on. A to the power 3 multiplied by a to the power 7. Now what you should consider is a to the power 3 multiplied by a to the power 7. That is what we have. So what did we say when you have such an expression? This is about indices, right? So you're going to get, because the bases are the same, you're going to have a. Then to the powers, what are you going to do? Because you're multiplying, what do? To the powers, you are going to add the powers, right? To be 3 plus 7. So what is going to be your final answer? You're going to have a to the power 3 plus 7. What does that give us? It gives us a 10. Okay, so therefore that's what you're going to write here. You're going to have a to the power 10. So therefore this is going to be your final answer. Okay, then let's solve another one in that same fashion. Let's say I've got okay, let's say I've got 24 b to the power 3 divided by 8 b to the power 2. What am I going to now do? Because this is a number and this is a number. Solve the numbers first. Divide the numbers first because you're taught to divide. Then the letters again, solve them independent. We've got b there. One is to the power 3, the other one is to the power 2. So let's start with the numbers. 8 divided by 24 divided by 8. So if you have got 24 divided by 8, what what's your answer? How many times can 8 go into 24? It goes 3 times, right? So I'm going to have 3. Then now to the power to the letters. What letters do I have? I've got b to the power 3. I'm dividing it with b to the power 2. So what am I going to have? So I'm going to have b, because it's a common base, right? Then what do I do to the powers? Every time I'm dividing, I'm going to subtract the powers. So if I subtract the powers, what do I have? The powers, I've got 3, so it's going to be 3 minus 2. Now 3 minus 2, what will be our final answer? I'm going to have b. 3 minus 2, it is just a 1. So I'm going to have b to the power 1. Any number the power 1 is itself, right? So in this case I'm going to have a b. So I'm going to write my b here. So this will be our final answer. Okay, let's solve another one. Let's say I've got 2 e, let's say I have to e to the power 5, then I've got 3 outside. So how am I now going to solve this one? So what this means is that this 3 is multiplying with the 2, which is a number. This 3 is also multiplying with the e, that is to the power 5. Now we are multiplying with the powers, not the number itself, okay? So even this 3 is not multiplying with the e, but it is multiplying with the power of e, which is 5. Same, this 3 is not multiplying with the 2, no. It is multiplying with the power. So mostly students tend to make a mistake here. So what happens is that most of them, the wrong way, let's say this is the wrong way of solving it. Mostly that's how most of them solve them in the exams. So this 3, they are going to multiply with the 2. They are going to have 6. Then this 3, they are going to multiply with the e. They are going to have 3e to the power 5. And this is very wrong, okay? That's not how you are going to solve it. So how you are going to solve it is how we've been solving all of them. So you are going to write your 2. 2 as a power. When you haven't been given a power, always assume that the power is 1, okay? So therefore you are multiplying 3 multiplied by the 1 that you can see here. So you are going to have 2 to the power 3. Then you come to e. E has a power of 5. So that 5 you are multiplying with the 3. 3 multiplied by 5, that is a 15. So basically this will be your answer. So because you can't multiply 2 and e, they are different. We don't know what e is, but that's how you are going to leave your answer like that. So basically this is how you simplify. Anyway, let's continue simplifying more questions. Okay, let's say I've got r to the power negative 3 divided by r to the power negative 6. So what am I going to have? So the base is the same. I've got r, so I'm going to say r because the base is the same. Then what am I going to do to the powers? Because I'm dividing, every time I'm dividing to the powers, I'm subtracting them. So this is where again a lot of students tend to make mistakes. So get your negative 3, you are subtracting with your minus 6. The way they are, get your negative 3, subtract it minus your negative 6. Okay, so what are you now going to have? You're going to have r. Now negative 3, you write it, it's just the way it is, negative 3. Then you have a minus and another minus, and they are multiplying in that case. So minus and the minus, they'll give you a positive. So you have a positive 6. So now what are you going to have? You're going to have r, negative 3 plus 6. Every time you have, you are subtracting, and the signs are different. It means you're always subtracting. So in this case, negative 3 plus 6, that will give me a 3, and you always get the sign of the bigger number. Okay, so in this case we're going to get, because 6 is the one that is bigger, we're going to get the positive. That's why I've just written 3. Okay, so basically that will be our answer. Then the wrong way to solve this one, mostly students are going to say r minus 3, because they've seen that there's already a minus here, they're just going to write minus 6. That is the wrong way, because it's going to give you r every time you have the same sign. It means you are adding those numbers and you're going to get any sign. So in this case I'm going to have negative 9, because it means I'm adding 3 plus 6, but the sign, you're going to get the same sign. So in this case I'm going to have r to the power negative 9, which is different from this. So this is the wrong way of solving it. So always note what they've given you. So that is very important. Okay, Now let's solve about negatives. What if you have negative powers? What do you do? Negative powers. So every time you have a negative power, let's say we are given a to the power negative 4. So what this means is that this negative that you have, remember we were solving where we didn't have any negative. We had questions like a to the power negative, a to the power 2. A to the power 2 just means a times 2. What if we say now it is a to the power negative 2? Now the power is a negative. So what do you do? So let's solve this question. A to the power negative 4. This negative that they've put in front, it just means it's a 1. So because it's a 1, you're going to divide by, you write the same expression but now without a negative. So that's what it means. It means the negative becomes a 1. Then you're going to have a to the power 4 without the negative. So that's our final answer for this one. Let's solve another one. Let's say I've got 2 to the power negative 3. What is it going to give me? So what did you say the negative becomes? It's a 1 over, I'm going to have 2 to the power 3. Okay, basically that. Now we're just writing like that. We don't want to first solve. Let's say 5 to the power negative 1. How is it going to be? It means I'm going to have 1 over 5, right? To the power 1. And any number to the power 1 is itself. So it's 1 over 5. Now if I were to simplify now further, like say 2 to the power negative 3. I'm going to have the negative, we're saying it's becoming 1. So it is 1 over 2 to the power 3. Then I can solve it further if they tell me to simplify further. I'm going to maintain my 1, but I've got 2 to the power 3. 2 to the power 3 means 2 times 2 times 2, which will just give me an 8. Okay, since it's giving me an 8, I'm going to write the 8 where there is 2 to the power 3. So to be the answer will be 1 over 8. Okay, so basically that is how you solve most of these indices. Now let's solve some indices that are fractions, and we've already started. So we've already started solving indices with fractions. So a to the power negative m is not very much different from what we're solving. The negative becomes a 1, so I'm going to have 1 over a to the power m. That's what it means. Okay, so let's solve another one. Let's say I've got I've got 1 over, let's say 2 to the power negative 3. What is going to be my answer? Okay, now we've made it a bit interesting. So what this means, write your 1, just write the weight, just follow the step. You have the 1 there on top, so write the 1 divided by 2 to the power 3, 2 to the power negative 3, 2 to the power negative 3. What is it? We said if you have a negative, it's going to be 2 to the power, the negative becomes a 1, right? So you're going to have 1 over 2 to the power 3. So 2 to the power 3. Now 2 to the power 3 is what you're supposed to write here. Okay, so we're saying it is 1 over 2 to the power 3. Now there are two divisions, there's this division and this division. So basically you have to now write it properly. Write your 1. There's this is a division symbol, so divided by, what are we dividing? We're dividing it by 1 over 2 to the power 3. 1 over 2 to the power 3. Then you solve. 1 divided by 1 over 2 to the power 3. It is 2 times 2 times 2, which gives us 8. Okay, now we are dividing 1 divided by 1 over 8. So 1 divided by 1 over 8. You know that the division becomes a multiplication, and these ones are going to swap, right? So I'm going to have times 8 over 1. Okay, I've swapped them. Now 8 over 1 is just the same. You're dividing 1 into 8, which should still give you 8. Okay, so now what that means is 1 multiplied by 8, that will give you an 8. That will be your final answer. And these are the questions they like in the exam. Okay, because it combines a lot of concepts at the same time. Okay, so basically this is how you are going to solve those ones. Let's solve more questions. Let's say I've got 8 to the power 1 over 2. Oh, this is a fraction. So what are we going to do? Every time you're given such, if it's a fraction is 1 over something, 2 over something, 3 over 5. All those are fractions. Every time you're given the fraction, what your denominator is, it becomes the root. Okay, so in this case I'm going to write my 8. So I'll write my 8. Then what is this? 2 becomes the root, so it becomes the root. I'm going to put 2 here. Then the whole thing, it will be to the power what is on top. What is on top is a 1. Then I solve. Now 2, the square root of 8, it means a number that you're going to multiply by itself to give you 8. Okay, a number that you're going to multiply by itself to give you 8. Okay, in this case there's no number. Okay, because most are not going to be using a calculator, but if they tell you you have to punch that on a calculator, but they'll give you something that you can solve without a calculator. Let's say 8 to the power 1 over 3. Okay, since it's 8 to the power 1 over 3, they were saying the 3 becomes the root. Okay, so it's going to be 3. Then because it is 3 there, you're going to put 3. Then 8. Then what is on top becomes the power. Okay, now you're going to find out the cube root of 8. The cube root of 8 means you're looking for a number that you're going to multiply by itself 3 times to give you 8. And that is 2, right? If I do 2 multiplied by 2 multiplied by 2, it will give me 8, right? So that is the cube root. So therefore I'm going to have 2 to the power, I've got a 1 outside, so 1 to the power 1 is just a 2. So that's how you solve this one. Okay, let's simplify some more equations. So let's say simplify the following. Let's say number 1, A, we've been given to simplify 8 to the power 2 over 3. Then B, we've been given to solve, let's say 25 to the power 1 over 2 or half. Let's say C, we've been given to solve 3 over 4. Then there's a negative 2 outside. Okay, so basically how do we solve these ones? So let's start with the first one. 2 h to the power 2 over 3. What did we say? This one that is down becomes the root. Okay, so therefore I'm going to have the cube root. Okay, if there was 4 here, it would have been 4 here. Okay, if there was 5 there, if there was 5 here, it would have been 5 here. Okay, if there was 2 there, if there was 2 here, we would have put a 2 here, which means a square root. So basically that is just our interpretation. So because we have a 3 here, I'm going to put a 3 here. Okay, then what am I? We're solving 8. So 8, I'm going to put it in the same root. Then what is on top? It becomes the power, which is 2. If I had a 5 here, it means I would have put a 5 here as well. So basically that's what we're talking about. But because we have a 2, I'm going to put a 2. Then I solve. So a cube root just means a number that you're going to multiply by itself to give you 8 3 times. Okay, 3 times. If we had the 4 here, we would have been looking for a number that we're going to multiply by itself 4 times, and it gives us 8. Okay, that's what that means. But now because we have 3, we're looking for a number that we're going to multiply by itself 3 times. By itself, we mean if I multiply 2 multiplied by 2 multiplied by 2. All these ones are 2. Itself, but 3 times. So that gives us an 8. So basically that. And that's the answer there. So we're going to have a 2. Now don't forget, so this whole thing gives us a 2. But don't forget there's a power outside. So write your power outside. Now 2 to the power 2, that gives us a 4. So it gives us a 4. So basically that will be our answer. Okay, so allow me to wrap just this part. Let's solve B. So how we're going to solve B is the same principle. Because we have a 2 here down, we're going to find the square root. If you want, you can put a 2 here, or if you want, you can leave it like that. It's still the same. Of 25, then there's a 1 outside. So a 1 just means it will still give us the same answer, right? Because it's just a 1, unless if it was a 2. Now the square root of 25 and okay, the square root of a 25. If I want, I can put a 2 here. It's still the same, okay? But mostly in the exam, they won't put it. They won't put a 2 here, but it's still the same. So a number that you're going to multiply by itself 2 times to give you 25. You know that it is 5 times 5, right? 5 times 5 gives us 25. So therefore, I'm going to have 5 there. To the power, the 1, don't forget the power. The power is 1. 5 to the power 1 is just 5. So basically, that's how we solve this one. Now let's solve C. So for C, we are given 3 over 4 to the power negative 2. Okay, this is interesting. So I've got 3 over 4 to the power negative 2. So what did we say when you have a power outside? It's multiplying with the power, not the actual numbers. It's multiplying with the powers of these numbers that are inside here. Okay? So now let me ask, what power does 3 have here? Because they haven't given us a power, so the power is 1. What power does 4 have here? They also haven't given us a power, so the power is 1. So now the negative 2 is going to multiply by all those ones on these numbers. So let's start with the first 3 on top. We're saying it has a power of 1. So 1 multiplied by the negative 2. It will give us the same negative 2, right? So I have a negative 2 here. Then there's a division here. So you're going to now come to 4. 4, we are saying it has a power of 1 as well. So we are going to multiply 1 multiplied by the negative 2. It will still be negative 2, right? So our 4 to the power negative 2. Now if I solve, we're going to solve the way we've been solving all these other ones. 3 to the power negative 2. What does it give us? So 3 to the power negative 2, we said, how have you been solving negatives? Every time you have a negative on top, a negative 2, the negative becomes a 1. That's what we've said. So we are going to have 1 over 3 to the power 2. Okay? That's what that means. That's what this expression means. Then what about for the 4? Same for the 4, this one. It is going to be what? If I've got 4 to the power negative 2. 4 to the power negative 2, the negative becomes a 1. So the negative becomes a 1. So I'm going to have a 1 over 4 to the power 2. So these are the two expressions that I have. If I solve them further, okay, before I even solve them further, because they are dividing here, so it just means I'm dividing them. Okay, so let me divide them. So what are we dividing? We're dividing this by that. Okay, so we're dividing 1 over 3 to the power 2 divided by 1 over 4 to the power 2. So basically that is what we have. Then now when we solve, what are we now going to have? We're going to have, let's solve this first one, 1 over 3 to the power 2. It's 3 to the power 2. We're saying it means 3 times 3. 3 times 3, what does it give us? It gives us a 9. Then don't forget you have a division here. Then you come to the other side. On the other side we've got a 1 divided by 4 to the power 2. What does 4 to the power 2 gives us? 4 to the power 2 means 4 multiplied by a 4. 4 by 4, that gives us a 16. Okay, so we have a 16 there. So we're going to have a 16 here. Okay, now that we've got that, what do we now do? We just solve what we have. Okay, so normal algebra, 1 over 9, then we're dividing. So whenever you're dividing, you change the symbol, right? So it becomes times. And whenever you change, this one goes on top, this one comes down. Okay, the one comes down. So basically that's what we're going to have. We're going to have 16 go on top and 1 come down. Then you solve. 1 multiplied by 16, that is a 16. 9 multiplied by 1, that is a 9. So basically that will be your answer. Then if they tell you to, you can leave it here, or if they tell you to simplify it further, you can divide 9 into 16. 9 into 16, what does it give us? It gives us a 1. Remember what? 7 over 9. If they want you to express it as a mixed fraction. So basically that is how you are going to solve this one. Okay, so on fractional indices, basically these are just some of the concepts that you are supposed to understand. Let's solve some more to just familiarize ourselves with these concepts, because most of the time in the exam they like fractional indices. Okay, so 125, let's say to the power 1 over 3. How are you going to solve it? So we've said the 3 that is down becomes the root, so I'm going to have the cube root, then a cube root of 125. Then we have a 1 as a power, so because the 1 is on top, it's going to become the power there. Okay, therefore now we're finding the cube root of 125. We're looking for a number that is going to, that we're going to multiply by itself to give us a 125. Okay, mostly they are going to give you, they're going to get almost the common numbers. Okay, if it's in the exam, like 125, 100, 16, those numbers that are easy, that you can even master every time they give you 9. Okay, so in this case the cube root of 125, it is a 5. Then you have a power of 1, so 5 to the power 1 is just 5 itself, right? So basically that's how you're going to solve this one. Let's solve another one. So I can be pausing the video like we've been doing. 5 to the power 5 over 2 divided to the power negative 2. So what are you going to have? So we have a negative 2 here. What did we say when we have a negative outside? It is going to multiply with the powers of everything, of the individual numbers that you have inside. So the power of 5 here is what? This negative 2 is not multiplying with the 5. I'm always emphasizing. This negative 2 is multiplying with the powers of these numbers. What does the power have? If they haven't given you the power is 1. So therefore we're just going to have 5. That then the power of 5, it is 1. So it's multiplying by this negative 2. So which will give me a negative 2 over, when I come to the 2 down, also it has a power of negative 1. It has a power of 1. So therefore I'm just multiplying the 1 multiplied by the negative 2. So it is a negative 2. Then I solve. Now 5 to the power negative 2, what did we say? Okay, it will be 1 over 5 to the power 2. Okay, then we have a division here, so write the division. Then come to the other side, the one that is down. The one that is down is 2 to the power negative 2. The negative becomes a 1 over 2 to the power 2. Okay, then you solve this. 1 over 5 to the power 2, that means 5 times 5. Okay, that is 10. That is 25. Divided by 1 over 2 to the power 2, that is a 4. Okay, that is what we have for now. Now what do we now do? We're just now supposed to divide. So we have 1 over 25 divided by 1 over 4. Now if we simplify this, what are we going to have? We're going to have 1 over 25. Every time you are dividing, you know the symbol changes. It changes to multiplication. Then what do you do to your your numbers here? The denominator goes on top, the numerator comes down. Okay, so in this case I'm going to have 4 on top over 1. Then what do? I just have to solve. 1 multiplied by a 4, that gives me a 4. 25 multiplied by a 1 on the other side, that gives me a 25. If there's no number that can go into these two numbers, or that can divide into both numbers, then you leave it just here. That will be your final answer. Okay, so that's how we solve this one. Okay, let's make it interesting. Let's say you're given 4 over, let's say 9. Then let's say you have 1 over 2 as a power. So what does that mean? This 1 over 2 is going to fall on, if you want, it's going to fall on the 4 and on the 9. Okay, because what this means is that you are multiplying by the powers of this one as a power of 1, this one as a power of 1. Okay, so therefore I'm going to have 4 to the power half divided by 9 to the power half. Now if I continue solving this one, I'm going to have, now the 2 there, we are saying it becomes the root, right? Because this is a fraction. So I'm going to have the root of 4 on top. When I come down here, same, the 2 here becomes the root. Okay, so I'm going to have the square root of 9. Then I solve. On top, what is the square root of 2? A number that you're going to multiply by itself to give you a 4. That is a 2, right? If I say 2 multiplied by 2, it will give me a 4. So I'm going to have a 2 over the square root of 9. A number that I'm going to multiply by itself 2 times to give me a 9. 3 multiplied by 3. It's 3 multiplied by itself. It's going to give me a 9. So basically that is here. So that is our final answer. Okay, so that's how we solve this one. Okay, let's simplify another one. Let's say you are given 8 negative 2 over 3. What are you going to do? So it's the same thing. This 3 becomes the root. So it's going to be the cube root of 8. Then what is on top goes down. It becomes the power this side, be negative 2. Then let's solve what is in the bracket. What is in the bracket? We're finding the cube root of 8. A number that I'm going to multiply by 3 times by itself to give me an 8. So 2 multiplied by 2 multiplied by 2 will give me an 8, because 2 multiplied by 2, that is a 4. A 4 multiplied by 2, that gives me an 8. So I'll have a 2 in the bracket. Then I have a negative 2 outside. So I'm going to have a negative 2 outside. Then what am I supposed to now solve? Now this has a power of 1, so I'm just solving 2 to the power negative 2. Now 2 to the power negative 2, what did we say? Every time you have a negative, the negative becomes a 1. So I'm going to have a 1 over 2 to the power 2. Okay, Then I solve 1 over 2 to the power 2, that is a 4. So that will be our final answer. Okay, so basically that. Okay, let's solve some more questions. Let's say you've been told to solve let's say the square root of a, then you have a 3 outside. You have been told to write it as an index. How can you write it as an index? Meaning, how can you write it as a for it to have a power? So get the a that is in there, then for it to have this square root, it means it had 1 over 3. That would be your final answer. What do I mean? Because you remember that if it was a 1 over 3, the 3 becomes the cube root, right? So it's going to become the cube root of a. Then the power is going to go outside. Now anything the power 1 is itself. So basically it's going to be like this. That's how we're going to solve this one. What if they've given you the square root of 32? You express it as a power. So it's the same thing. For it to have a square root, meaning it was half, right? So 3, 2, half. Okay, so if you want to also continue simplifying it further, 32 can also be written as 2 times 2 times 2 times 2 times 2. So 32, when you multiply 2 by itself 5 times, it's going to give you 32. So that is 2 to the power 5. 2 to the power 5. Then there's a half outside, don't forget. Then if you want to again simplify it further, you're going to have 2. Then the powers now can multiply. This has the power of 2 and this has the power of half. Half multiplied by 5. So it just means 5 multiplied by the 1 here. You're going to have 5. Then over, you have a 2 down there. So you write your 2 there. So that is your answer. Okay, let's solve questions where you're given also x. Let's say x squared multiplied by x to the power 4 over, let's say x to the power 3. So how are you going to solve this one? So solve on top we are multiplying. The same rule applies when you are multiplying and you have the same bases. What do you do to the powers? You add them, right? So we're going to have x 2 plus 4 on top over x to the power 3. Then we solve x 2 plus 4, that is a 6, right? Divided by x to the power 3. Okay, so if you want now, what are you going to do? You have x to the power 6 over x to the power 3. Because they are dividing in the same base, you can subtract the powers like we always do, or expand. So if I'm going to expand this, x to the power 6 means I'm multiplying x by itself 6 times. X multiplied by x, multiplied by x, multiplied by x, multiplied by x. How many are they? 1, 2, 3, 4, 5. Multiplied by x over x to the power 3 means I'm multiplying x by itself 3 times. X multiplied by x, multiplied by x. Now that I've got that, I'm going to now divide or cancel the x's on top and down. So I cancel this one, I cancel this one. This one and this one are going to go. This one and this one are going to go. Everything down has been exhausted. Now we're just remaining with what we have on top, which is we've got x times x times x. There are 3 of them. X times x times x is just x to the power 3 because there are 3 of them. So that will be your final answer. Or the way we've been doing, because we're dividing, allow me to just write it just this same, that's just same here on the same page. We have x to the power 6 over x to the power 3. The over means you are dividing, right? So it just means you are dividing by x to the power 3 down. So now how do you solve this one? Like we've always been doing, because the bases are the same, you're going to subtract the powers. So x 6 minus 3. Why you're subtracting the powers? It's because we're dividing. Then you solve. You're going to have x 6 minus 3. That gives us a 3. So basically that you're able to see that it also gives you x to the power 3. So basically that's how you solve these questions. Okay, now let's solve some indices to do with equations. So how do you solve when you're given equations? So the whole principle is about you making the base the same. Okay, that's the whole principle. Let's say I've got 2 to the power x. Since we're solving an equation, every time we introduce equation, it means you're either finding the value of x, mostly you're finding the value of x, but you can also be asked to find the value of y. So if I've given 2 to the power x, let's say this is equals to 8. Because we've introduced an x, it's an equation. So in the exam, be able to differentiate, like, okay, this one, they've just told me to simplify. Okay, sometimes they'll just say solve. So from solving, are they asking me to just simplify or to solve as an equation? Now if you see x, sometimes x can be simplifying, you are just leaving it as x, but like in this case they are numbers. It means you're finding what the value of x is. Okay, so they'll not always tell you to solve an equation. Sometimes they just say solve or simplify. This same one, they can tell you to simplify, but because there's an x, it's an equation. Okay, so now let's solve. So every time they give you such an equation, make the bases on all the sides the same. So this is our, let's say this is our left hand side, and let's say this is our right hand side. So which base can we make to be common on both sides? So we can only make the base to be 2 on both sides. So I'm going to have 2 to the power x on my left hand side. When I come to my right hand side, how can I write this in terms of 2? We said 8 is the same as 2 times 2 times 2, right? So in this case, it's just going to be 2 times 2 to the power 3, because 2 times 2 times 2 is just the same as 2 to the power 3. Now that we have the same bases on both sides, what are we going to do? We're going to cancel the bases and equate what we have as the powers. So I'm going to cancel this and cancel that. Then what I have, I'm going to equate them. So I'm going to equate them, meaning I'm going to have x is equals to 3. That is our answer. Now the goodness with math is that you can prove this one if it's your answer in the exam. Okay, how are you going to prove? Try to put the 3 where you've found the answer, because you're saying that where there's x there, the answer is 3. Okay, so try to put it back and try to verify if it's the answer. So if I say 2, where there's the x here, if I put a 3, is it really going to give me an 8? Okay, so 2 to the power 3, it just means 2 times 2 times 2 times 2. So 2 times 2 times 2 is equals to 8. Is 2 times 2 times 2 equals to 8? 2 times 2, that is 4. 4 multiplied by 2, that is an 8. So basically you're going to have 8 is equals to 8. Every time you see something like this in the exam, meaning you're very sure that that is the correct answer. So basically that's how we solve. Let's solve some more questions. So now let's say we've been told to simplify. Let's say let's make it interesting. Let's say I've given 2x plus 1 is equals to 64. Like we've said, every time they've given you something like an x and their numbers, just know that you're solving an equation. You're trying to find the value of x in that expression. So in this case, how can we make 6 to the power of 2? 64 to the power of 2. Because here we already have 2, it's already simplified, but this one is a big number. You can make it as a power as well. So every time they give you a big number like this, Sometimes if you don't know exactly how you're going to go about it, just start dividing the same number on the other side into this number one by one. Okay, so let's start. 64 divided by 2. What does it give me? 2 into 6, that is a 3. 2 into okay, let's draw it like this. How did you used to draw it in grade 5? So in grade 5 we used to draw it like this. Then this is 64, this is a 2. Okay, yes. So what do? We say 2 into 6, that is a 3. 2 into 4, that is a 2. Then we drop the 2 again. So I'm going to write the 2 here again. Again, we're going to divide 2 into this number. So 2 into 3, that is a 1. Okay, remainder 1. Right? Remainder 1. So the remainder is going to fall on the 2. Then it becomes 12. 2 into 12, that is a 6. Then again, I'm going to drop the 2 until I reach to the smallest number. So again, I start 2 into 1. You know that 2 can't go into 1, but now therefore I'm going to carry that 1. 2 into 16, that is an 8. Okay, then again I'm going to drop the 2. So if I drop the 2 again, 2 into 8, what does it give me? It gives me a 4. So it gives me a 4. Since it is giving me a 4, again I'm going to divide by 2 until I reach to the 2 that I want. 2 divided into 4. 2 divided into 4, that is a 2. Again I'm going to drop the 2 until I reach to the smallest number. 2. 2 into 2. 2 into 2, that just gives me a 1. So once I have the lowest number less than 2, I'm stopping. Okay, because if I put a 2 again here, 2 cannot go into 1. Okay, so basically I'm going to end it there. So now I'm going to count all the 2's that I have. How many 2's do I have? I've got 1, 2, 3, 4, 5, 6. So since I've got 6 of them, what this means now, I'm now going to just say 2 to the power 6. Okay, so therefore if I simplify it, I'm going to have 2x plus 1 will be equals to 2 to the power 6. That's the 64 on the other side. Okay, so basically allow me to wrap this, then we solve. Now we've said on an equation, when you have the bases on equals when the base is the same on both sides, just cancel the base and equate the powers. So now let's equate the powers. So we're going to have x plus 1 is equals to 6. Then we know how we solve equations. We put the like terms together. So x will be equals to 6. The 1 is going to go on the other side because that's where the 6 is. And when it crosses the equal sign, it changes the symbol. Okay, this is positive, it's going to become negative on the other side. So I have a negative 1. Therefore x will be equals to 6 minus 1. 6 minus 1, that is a 5. Therefore our answer there, it is a 5. X is equals to 5. Then like we said, you can still prove if if you put 5 there, it's going to give you 64. Let's prove, because that's what will be giving you marks. If you prove and you even know, okay, that one I know what I've gotten in the exam, I can't fail that exam because I know that that one I got it. So let's put 2. Our question is 2x plus 1 is equals to 64. Since we found our x to be 5, where there is x, let's put 5. So I'm going to have 5 plus 1 is equals to 64. 2. 5 plus 1, now what does it give us? 5 plus 1 gives us a 6. This is equals to 64. 2 to the power 6, what did we say? We solved this one and it gave us 64. So 64 is equals to 64. Therefore, when you solve like this, you are very sure that your answer is correct. Let's solve another one. Let's say they've given you 5 x minus 1 is equals to 125. Now, how are you going to now solve this one? So, again, make the bases to be the same. This is 5, this is 125. They are not the same. So, get the big number. Start dividing it by 5. The number that you have on this side. So, 5. You draw what we had drawn per first. Okay, so let's draw it nicely now. Okay. So now, 5, we start dividing one by one. 5 into 1, it can't go. 5 into 12. 5 can go into 12. Okay, how many times? 2 times. Remainder 2. Okay. Then 5 into 25 on the other side, it is 5. Then we drop the 5 again, like we are doing. Then again we divide. 5 into 2 it can't go, but 5 into 25 it can go. 5 into 25, that is a 5. Again we drop the 5. We want to reach to the smallest number as possible. 5 into 5, that gives us a 1. Okay, it gives us a 1. Now because 1 is the smallest number, we are not going to divide anymore, because if I put another 5 here, 5 into 1, it can't just go there. Okay, so basically we are going to end here. Then we are going to count the number of 5s that we have. How many do we have? 1, 2, 3. Since we have 3, so therefore I'm going to have 5x minus 1 is equals to, this 125 is the same as 5 to the power 3 from what we are just from calculating. Now that the bases are the same, cancel the bases, then equate what you have as the powers. What do we have? We have x minus 1. This will be equals to the 3 on the other side. Then you put the like terms together. So I'm going to have x is equals to 3. When I take the negative 1 to the other side, it becomes a positive 1. So I'm going to have positive 1. Then x will be equals to 3 plus 1, that is equals to a 4. Basically, that will be our answer. How do we prove? Try to put a 4 there. Is it going to give you 125? Of course. If I put a 4 there, if I put a 4 there, if I say 5, 4 minus 1, okay, that would be 5. 4 minus 1, that is a 3. 5 to the power 3, we have said it gives us 125. So basically that's how you are going to solve this one. Okay, let's solve another one. Let's say we have x to the power 5 is equals to, let's say, 32. Okay, now this is very interesting. How do we solve such an expression? So since we're trying to find the value of x, what this means, what number are we going to put here on x, then it is raised to the power 5, then it's going to give us 32. And we know that if I put a 2 here where there is x, we said 2 to the power 5 gives us a 32. But now they want you to solve. Okay, if you want, you can go direct. Maybe you're just going to be given 1 mark, but you have to really solve. Okay, so in this case I'm going to have x to the power 5 is equals to 3 to the power 2. We know that it is 32. 32 is just the same as 2 to the power 5. Okay, now, or you are going to do the same thing that we did, but now since here we don't know the base, try smaller numbers. You're going to start from 2. Try to be dividing 2 into 32. You see what it's going to give you. It's going to give you to the power 5. But if 2 doesn't go into this number, go to 3. Okay, go to 3 because we don't know what this number is. Okay, so if 3 doesn't go also in that number, go to 4. You're just going to be going like that. Go to 5, go to 6, because we don't know what that number is. Try from the lowest number, which is 2. So in this case, if I say 2 here, then there's 32. Then I start dividing one by one. 2 into 32, 2 into 3, that is a 1. 3 into 12, it's a 1 carry 1. 2 into 12, that is a 6. Then again I'm going to draw the 2. 2 into 16, that is an 8. Then again I'm going to drop 2 into 8, that is a 4. Then 2 into 4, that is a 2. Then 2 into 2, that is a 1. So because 1 is the smallest number that I can have, then I'm going to count the 2s. I've got 1, I've got this one, I've got 1, 2, 3, 4, 5. That's why I'm saying 32 is the same as 2 to the power 5. Okay, so basically if you just know, you know. Okay, you don't have to show all this, but once you know and once you are practicing, you're going to know most of these combinations. So therefore, now that we've got 2 to the power 5, what do we do? Okay, we cancel the powers. Okay, why? Because the powers are the same. So what was your goal? Your goal is to make the power the same. Okay, in the previous ones we were making the bases to be the same because it was easy. But now once you see that you're not able to make the bases the same, because this is x and you're trying to find x, you don't know what x is, so you don't know the base. So what is your alternative? Go to the powers. Make sure that you make the powers to be the same. So now that the powers are the same, it is only unique in this case to cancel the powers because they are the same. So I'm going to cancel this power and I'm going to cancel this power. So since I've cancelled the powers, what do I now have? What I have now, it is x is equals to 2. Therefore, if I put, where there is x here, if I put 2 to the power 5, is it going to give me 32? Yes. So basically, that's how you solve this one. Okay. Now, let's solve just a few questions. Then I'm going to leave some questions for you to solve, just to familiarize yourselves with these concepts. Okay, let's say I've got 9 to the power x is equals to 27. 9 to the power x is equals to 27. What is it going to give us? Like we've said, in this case, look at the bases. These are numbers. It's easy to make sure that they have the same base. Okay, so it means we're just finding the power in this case. So in this case, what are we going to do? Can 9 be expressed as 27? So if we say 9 and we do 27, 9 into 27, it is 9 into 27, that is a 3. Then 9 cannot go into 3. So basically 9 can't work. Okay, because the lowest possible number that you want to have a 1, not a number like a 3. So 9 can't work. So try to now reduce what you have to at least a common number like 3. Since it has given you 3, it has given you a clue. So in this case, make 9 to be a 3, make 27 to also be a 3. So how can you make 9 to be a 3? It is 2 to the power, it is 3 to the power 2, right? 3 squared, it just means that 3 times 3, that gives you a 9. Okay, then don't forget you have an x outside. Put it is equals to. Then you have a 27. 27, how can you write it in terms of 3? 27 is just the same as 3 times 3 times 3. Why? Because 3 times 3, it is 9. 9 times 3, that is 27. So basically that. So this is just the same as 3 to the power 3. Okay, now what did we say when you have a number outside and you have a power? Multiply the powers. So therefore this side, on my left hand side, I'm going to have 3 to the power 2x, okay, is equals to, the other side I'm going to just have 3 to the power 3. Now that I've got this, what I now do is I'm now going to cancel the bases because they are the same. I'm cancel this one and I'm cancel this one. Then I'm going to equate the powers, what I have on top. What do I have? I have 2x is equals to 3. So for me to remain with x, which we are finding, I'm going to divide by 2 on both sides. Therefore, what will be my final answer? X will be equals to 3 over 2. That will be my final answer in this case. So basically this. Okay. Then let's solve another interesting one. Let's say you are given 2x plus 6 is equals to 16 to the power negative x. Again, always try to make sure that the bases are the same. So I'm going to have 2x plus 16 is equals to, how can we make 16 to the base of 2? Okay, just the same, they are just the same method that we've been using. You do that and you do this, the plus method. So I'm going to put a 2 here and I'm going to put a 16 here. Then I'm going to be dividing 2 into 16, that is an 8. Then I drop the 2. 2 into 8, that is a 4. Then again I drop the 2. 2 into 4, that is a 2. Then again I drop the 2. 2 into 2, that is a 1. Once I reach to a 1, it means it's correct there. Then I'm now going to count the number of 2's that I have. I've got 1, 2, 3, and 4. Therefore I'm going to have 2 to the power 4. Now that I've got the bases to be the same, I'm just going to cancel the bases. This one and this one, I'm going to cancel them. Then I equate the powers. 2x plus 6 is equals to 4. Okay, we continue. Then what are we going to do? Put the like terms together. So I'm going to remain with 2x is equals to the 6. When it comes to the other side, it becomes a positive. So I'm going to have 4 minus 6. Okay, so I'm going to have 2x is equals to 4 minus 6, that gives us a negative 2. Then for me to remain with my x, which we are trying to find, I'm going to divide by 2 on both sides. Therefore x will be equals to negative 2 divided by 2. That gives us what? A negative 1, right? Negative 1. So basically that is going to be our answer for this one. Okay, let's solve another combination. Let's say you are given 9x is equals to 27. So 9x is equals to 27. What are we going to do? Okay, I think we solved this one. Let's look for another combination that we can solve. Let's say we have 2x minus 1 is equals to 1 over 8. So try to make sure that the base is the same. So I'm going to have 2x minus 1 is equals to, how can I make this? You know that before it became 1 over 8, the 1 we said is the same as a negative, right? So this is just the same as 8 to the power negative 1, okay? So if it was 8 to the power negative 1, what this means is that the the negative becomes a 1, okay, like we've always been doing. The negative becomes 1 over 8 the power 1. 8 the power 1 is just the same as 8. So that is what we have there. That's why we're saying it is the same as 8 to the power negative 1. Now that we've got this, how do we now make the bases to be the same? We have 2 here, we have 8. How do we make 8 to be to a base of 2? So this is just going to be maintained. 2x minus 1 is equals to 8 is the same as 2 to the power 3, right? Then don't forget you have a negative there. So I'm going to put this one in bracket to represent 8 to the power 3 as 8, then the negative 1 outside. Then now that I've got this, this one I can multiply. 3 multiplied by the negative 1 gives me negative 3, right? So based on that, I can now cancel the bases. This one and this one, they are the same. The 2 and the 2 are going to cancel. Now what do I remain with? I've got x minus 1 is equals to, I've got a 3 that is multiplied by a negative 1. That will give me a negative 3. Then I have to put the like terms together. So to be x is equals to, the negative 1 when it comes to the other side, it becomes a positive. So I'm going to have negative 3 plus 1. Then what do I now have? I'm going to have x is equals to negative 3 plus 1. Because the symbols are different, or the signs are different, it means I'm subtracting. Then I'm getting the sign of the bigger number. In this case, the bigger number is 3. So I'm going to have a negative answer. But when I subtract 3 and 1, that gives me a 2. So basically that. Then how do we do? You always prove to just try to find out if it is your answer there. Okay, since we haven't been proving for a while, let's just try to also prove this one. So let's prove. We found that x is equals to negative 2. X is equals to what? Yeah, x is equals to negative 2. So if we're going to prove 2 to the power, where there's x, we put negative 2 minus 1. Is it going to give us 1 over 8? Let's try. So 2, negative 2 minus 1. Because the signs are the same, you are adding them and you're getting any of the signs. So I'm going to have negative 3. I'm adding them, right? Is it equals to 1 over 8? Okay. Now, the negative here becomes, like we've said, it becomes a 1, okay? So I'm going to have a 1 over 2 to the power 3. Is it equals to 1 over 8? Okay, then let's continue. 1 over 2 over 3, that is an 8, is equals to 1 over 8. So able to see that it gives us the same answer still. So basically, that's how you simplify. Let's solve the last two. I was supposed to give you like as questions to solve, but let's just solve them. Okay, so let's say you are given 5, then you are given x minus 1, let's say is equals to 75. So how are you going to solve this one? Like we said, always make the bases to be the same. So we have a 5 this side, it's the smallest one. So let's try to divide it into 75. So we're going to draw, this is 75, this is 5. So if I divide 5 into 75, so let me start with 7. 5 into 7, it gives me a 1. A 1, remainder a 2. 5 into 25, 5 into 25, that gives me a 5. Is it? Okay, then I drop the 5. 5 into 15, that is a 3. Okay, that is a 3. Okay, so this, it means this one can't work. So let me modify the question a bit to make it work. So if I'm going to make it work, I'm going to assume that, okay, this is alone, then I put a 3 outside. Okay, so we modified our question. So now how are we now going to solve? because we have a 3 outside, we're going to divide by 3 on both sides. So here I'm going to divide by 3, and the other side I'm going to divide by 3. So the 3 and the 3 this side, they're going to cancel. I'm going to have 5x minus 1 is equals to 3 into 75. So 3 into 7, that gives us a 2, remainder 1. 3 into 15, that gives us a 5. Okay, now like this we can solve. So we're going to make sure that the bases are the same on both sides. Is equals to 25 in terms of 5. How can we write it? It's just the same as 5 to the power 2, right? If I multiply 5 by itself 2 times, will give me 25. Now that I've got this, I'm going to cancel the bases. Now that I've cancelled the bases, I'm just going to equate the powers. X minus 1 will be equals to 2. Then x will be equals to 2. When I come to 1, when 1 goes to the other side, it becomes a positive 1. Therefore x will be equals to 3. X is equals to 3. Let's just try to find out if really x is equals to 3. So allow me to wrap this part. So I've wrapped that part. Then I'm going to say 3, that's what we have. We have 5. Where there's x, if I put 3 minus 1, is this whole expression going to give me 75? That's the question. Okay, so we have 3. Let's multiply, let's solve the powers. So I've got 5. 3 minus 1, that gives me a 2. This is equals to 75. Okay, then 5 squared, that gives us a 25. It's equals to 75. Is 3 multiplied by 25 equals to 75? Let's try. So if I've got 25 multiplied by 3, 3 multiplied by 5, that is a 15. Carry 1. 3 multiplied by 2, that gives us a 6, plus this 1, that gives us a 75. So that's this 75 equals to 75. So basically our answer is correct. Okay, so basically that's how you solve these questions. Let's solve the last question. Okay, I think we've solved almost everything. Let's solve the last question. Let's say you have 3x times the square root of x is equals to 81. Okay, so how do we solve this question? So basically, like we've been doing, we're trying to find the value of x. Okay, so let me just write the question nicely. Let's say this is 3 to the power x. Okay, not 3x. This is multiplying by the square root of x is equals to 81. Okay, now that we've got this, what do we now do? So it's not very much different from the previous ones. So we're going to do, this will be 3 to the power x multiplied by the square root of x. We know that the square root is just the same as half a square root. So all the while we've been solving, you've realized that the square root is just the same as 1 over 2, right? Then the cube root is just the same as 1 over 3. If we have the fourth brood, it is 1 over 4. If we have the fifth brood, it is 1 over 5. If you have the sixth brood, like that, that's how it is. So basically that. So if you see something like this, be quick to catch it up that okay, this is what they're asking about. So in this case, how are we going to do that? So I'm going to have x to the power half, okay, is equals to 81. Okay, now that we've got this 81, can 81 be written in the form of 3? Okay, can it be written in the form of 3? Let's try. Why I'm asking like that is because this 3 to the power x is multiplying with x to the power half. So if I multiply, I'm going to have 3 to the power x, x to the power half is equals to 81. Okay, so even here, I think we can just solve it. We can divide by 3 on both sides. Yeah, then we will do that. What are we going to like have? Okay, no, we can't do that because this has a power. This is not 3 independently, it has a power of x, so we can't do that. So basically we just have to first make sure that this also has a power of 3. So in this case, let's start 3. We draw our plus. This is 81. Then we start dividing. 3 into 8, that is a 2. Carry 2. 3 into 21, that is a 7. We drop the 3. 3 into 27, that is a 9. We drop the 3. 3 into 9, that is a 3. Again we drop the 3. 3 into 3, that is a 1. So every time you have a 1, you stop there, you close. Then you count the number of 3's that you have. How many do we have? We've got 1, 2, 3, 4. So because we've got 4, 81 is the same as 3 to the power 4. So I'm going to have 3 x half to the power half is equals to 3 to the power 4. Okay, now that we've got this, what do we now do? Okay, this question is very, very interesting. How do I make sure that the bases are the same? Because I'm trying to create this question in my head and I'm trying to make it work. Okay, trying to make it work. Okay, so I think there's somewhere where I must have made a mistake to solve this question, but this is how I'm going to manipulate it, because the question was just initially wrong. So I'm going to cancel the x. That's the only way it can be solved. The other way was just a mistake. We can't solve it like that. So I've removed the x because at least 3 now can be divided on both sides. So like earlier, initially we saw we couldn't divide 3 on both sides because of the x that we had. Okay, because we don't know what that x is. So we're going to now divide by 3 on both sides. So 3 here and 3 that side. So the 3 and the 3 are going to cancel. Then I'm going to have x1 over 2 will be equals to 3 to the power 4. We say that is 81. 3 into 81, what is it going to give us? It's going to give us 9, right? Because 3 times 3, 3 times 3, 3 times 3, that is a 9. 3 times 3, that is also a 9. 9 times 9, it gives us 81. So basically that is our answer. So our answer is x is equals to 9. So let's just prove if x is 9 in this case. Okay, so we've got 3 multiplied by, where there is x we're putting 9. This is equals to 81. We're trying to prove. So we have 3 multiplied by the square root of 9, a number that you're going to multiply by itself 2 times to give you 9. That is a 3. 2 times by itself to give you a 3. Yes, we're going to have 81. This is going to be equals to what? What are we going to like have? We're going to have 9 is equals to 81. Okay, so this question initially it was just never correct, so it can't be solved. So this one can't be solved. Okay, so basically this is how we simplify. So this can be solved because it's like I failed to make the correct question. Okay, I think we've solved almost all the combinations. Maybe let's just solve the last one, which has fractions, then we are done. Okay, let's say you are given 3 to the power 0 plus 1 over, let's say you have 4 to the power half. What is it going to give us? So we're going to say 3 to the power 1, 3 to the power 0, that is a 1, plus a 1 over what 4 to the power half means is what we said. If you have a half, that just means the square root, so that is the square root of 4. Then 1 over 1 plus 1 on top, that will give us a 2 over the square root of a 4, that will also give us a 2. Then a 2 divided by 2, that gives us a 1. So that's how you solve when you're given such a fraction. Okay, let's put now the fourth brood. Let's say you're given 3 to the power a times 9 a plus 1 everything over, let's say 27 a plus 2. So what are you going to now do? Okay, so since these ones are multiplying, so they are multiplying but they don't have the same base, so I'm just going to multiply them the way they are. And to the powers, make sure that you are very much careful, okay, because you're also going to multiply the powers, so you have to be very, very careful here. Okay, so basically, unless if you want to first change the powers, so if we change the unless if you want to change the bases, so it's going to be this, the cube root, the fourth brood of 3a multiplied by 9. 9 can also be written as 3 to the power 2, right? This is going to multiply by a plus 1 over, we have 27 a plus 2. Now that you've got that, you are going to continue with the fourth brood. Because you have the same base, you can now get the base and add the powers. So you're going to have you're going to have 3 these three, we have a, because you're multiplying, you're going to add the powers. A plus, you're adding with this, but this has to be simplified. How is it going to be simplified? You're expanding. 2 multiplied by everything that is in the bracket. So 2 multiplied by a, that is a 2a. Then again 2 multiplied by the 1 on the other side, you are going to have a 2. So plus 2. That's what you have down over okay, over 27 over a plus 2. Okay, now that we've got that, what do we now do? Allow me to rub this part. Okay, what are we going to have on top? Okay, we're going to have the fourth brood. Don't leave your brood. We're going to have 3, 2. We're going to add now a plus 2a, that is a 3a plus 2, over down we've got 27a plus 2. Okay, so we are dividing these two terms. So what are we going to do now? Allow me to now just get what is in the root and try to solve it independently. Then we're going to take it back. So we've got 3a plus 2. We are dividing this by 27a plus 2. So we can also make this one to have the same base, right? So we're going to have 3a plus 2. The division, if you are dividing, let's maintain it first. Then 27 can also be made as 3 to the power 3, right? This you are going to have 3a plus 2. Okay, now that we've got this, because the bases are the same, what do? You're just going to get one of them. Then what are you going to do to the powers? You're going to subtract the powers. So what are we subtracting? We're subtracting 3a plus 2. This was subtracting from minus 3a plus 2. So that is what we have. We're going to have now 3. Then we're going to have the powers. What are we going to do to the powers? So this is going to maintain first 3a plus 2. Then we have a negative 3. The negative 3 is going to multiply with everything that is in the bracket because it's outside. Now when we say negative 3 multiplied by 3a, that will give us negative 9a. Okay, then negative 3 multiplied by 2, that will give me negative 6. Then when we simplify the powers, what are we going to have? I'm going to maintain my 3. Then to the powers, I'm going to put the like terms together. I've got a 3a here, I've got a 9a there, then I've got a 2 there, and I've got a negative 6. So I'm going to put them together. So if I've got a 3a plus 2 minus 9a minus 6, how am I going to solve it? So what I'm saying, I'm putting the like terms together. So I'm going to have 3a minus 9a plus 2 minus 6. And when I solve this, 3a minus 9a, that will give me negative 6a plus, not really plus, because I'm adding 2 minus 6. Because the signs are different, I'm going to get the symbol of the bigger number, which is negative. Then I'm going to subtract the 2. 2 and 6, that will just give me a 4. Okay, basically that is what I have here. So I have negative 6a minus 4. Okay, so if that is what I have, I'm just now supposed to put it there. So finding the fourth brood of 3 negative 6a minus 4. Okay, so basically this is where we're going to end from, because we don't know what a is. So basically you would have simplified it to its smallest number as possible. So basically this is how you solve these questions. Not hard, just straightforward questions. Okay, so at the end of this video, like I earlier said, I'm going to leave you with a question. So so you can, in your free time, you can solve this one. Solve and simplify. So you have to solve 2 to the power n multiplied by 8 to the power n plus 2 over 4 power 3n times 2 minus 2n. Okay, that is number 1. Number 2, you can solve the fourth brood of 3 to the power a times 3 2 a plus 2 over 3. We can put 3 a plus 2. Okay, we can put another one. Let's say you are given x to the power 2 times x to the power 4 over x to the power 3. Number 4, let's also put, just for refreshing, let's say 2 to the power x plus 1 is equals to 64. Okay, let's also put number 5. Let's say you are given to find 5 over 2 negative, let's say negative 3. Then let's try to put the last, no, 6. Question number 6, I'm going to put it in blue. Let's say you are given to solve let's say you are given to solve okay, let's say you're given to solve 4 to the power, okay, let me say m to the power 4 divided by, let's say, m to the power 7. Then the last one, let's say you're given to solve a 2 minus x times, let's say, a to the power x plus 1. Okay, so basically these are the questions that you can solve. Then as you are solving those questions, you can either pin them to the comment section or email us. So the email is on this same channel on top. You're going to see it at novastoneacademy.gmail.com. You can email your answers. We're going to review them and we're going to send you back with an email. So basically this is where we're going to end from for today. Thank you for watching our videos, and we're going to see you in other sessions. Have a good day, have a good evening, enjoy the rest of the day.